We'll be doing the intermediate challenge, which is to perform a static structural analysis on the model part in the beginner challenge that we did earlier on. Fix the front cylindrical face, apply a 9000 Newton downward force on the top inclined surface, report the von Mises stress and the maximum displacement. So that's just the requirements of this. So to go about this, we already created our parts in the previous exercise with this particular mass weight. So what we need to do is to perform an FE analysis on this part to know how it's going to behave under 9000 Newton force. So now I'll go to my simulation. Then I'll click new study. So what I want to do is to create a static study, so there's no need of clicking any other thing. I'll just click this, and then creating my static study, I have to assign material. The material is already assigned. You can see it if you edit material. This is your material that is assigned. What is the elastic modulus of this? You can see the elastic modulus, all the material property, the yield strength, and all that by using ABS. So tensile strength and all that. So apply. There's no need. Close. We've already applied it before. So what we need to do is to come here, connections. We don't need connections at all. What we need is a fixture to tell it where to fix. So fix geometry, you select here, tell because from the design it's already specified where we are to fix. Then our external load, this is just a simple FE analysis that anyone should be able to replicate. You click here and then tell it 9000 Newton, it's already Newton downward. So you click this. What you now need to do is to mesh. So you mesh and run. So your static solver will create all the necessary stuff that you need. It's a excessive displacement detected, unstable study setup, large deflections. Don't worry, just go ahead with that. So you can see that you've been able to create your static study, your FE analysis. Now you can see that these red areas are your area where your stress is concentrated. Now you can see from this is your von Mises stress, and you can see this is about 5.1159 Newton meter per second square. So this is high. Your von Mises stress is high at this point. Now you can see some areas of stressed at this point too much. So you can as well, if you want to see your displacement reports, you can see your displacement. It's your displacement is the area that is displaced more. So that if you want to generate your report, you can generate your report from here. You can either snap this and then send this as your report, or you can just convert this report into PDFs that you can say reports, and then you can say include images and all that. It will create the report for you for your von Mises stress. So we see in the following session where you are going to optimize the part. You see how to use topology optimization to reduce the material, so you create a more reduced part.